Earth shouldn't have oceans. Yet they cover more than 70% of its surface. Every river, every cloud, every drop of rain begins with the same contradiction. For decades, the simplest assumption was that Earth had always been a water world. The evidence no longer agrees. This investigation is not trying to prove one dramatic theory. It is trying to reconstruct the strongest explanation the evidence will allow. The evidence does not point to one certain answer. It does eliminate several familiar ones. That is where this investigation begins. Not with an ocean, not with a cloud, but before the first ocean could exist. More than 4.5 billion years ago, the young Earth was taking shape inside a violent solar system. Worlds grew by colliding with other worlds. Each impact released enough energy to melt enormous regions of the planet. According to planetary formation models, the surface became a global ocean of molten rock. The Earth was already forming, but its oceans were not. Temperatures remained far above the point where liquid water could survive. Any water reaching the surface would have become vapor almost immediately. Much of it would have escaped while the young planet was still struggling to hold on to its earliest atmosphere. The familiar picture begins to fail. The blue planet was not born blue. That changes everything. If Earth could not keep permanent oceans when it first formed, then the oceans covering the planet today cannot simply be leftovers from the beginning. The investigation has reached its first verified contradiction. The drop of water returns. Only now. It isn't there. Its absence is no longer ordinary. It is evidence. And until that missing water can be accounted for, every ocean on Earth remains part of an unfinished planetary investigation. The first explanation appears almost as soon as the question does. If Earth could not keep its water, perhaps it never had to. Perhaps the water arrived later, not as an ocean, not as rain, but locked inside ancient rocks that were already traveling through the young solar system. These were not ordinary meteorites. They were primitive, carbonaceous asteroids, remnants left over from the formation of the planets themselves. Long before Earth became recognizable, these bodies preserved minerals that had chemically bonded with water. The water was not frozen into great sheets of ice. It was built directly into the structure of the rock. That changed the investigation. Water was no longer something that belonged only to planets. It could survive the journey through space. Scientists carried those meteorites into laboratories and began asking a much more precise question. Did this extraterrestrial water resemble the water filling Earth's oceans today? The comparison did not rely on appearance. It relied on chemistry. Every sample of water carries a subtle fingerprint. Some water molecules contain ordinary hydrogen. Others contain a heavier form, known as deuterium. The ratio between the two remains remarkably stable over enormous periods of time, making it one of the most powerful forensic tools available to planetary scientists. When researchers measured that ratio inside primitive carbonaceous meteorites, they found something unexpected. The fingerprint closely matched the water found in Earth's oceans. The leading explanation had survived its first major test. This was no longer simply a rock from space. It had become physical evidence that water traveled through the solar system long before oceans existed on Earth. For the first time, the investigation possessed a mechanism that agreed with both planetary physics and laboratory measurements. The drop of water returns. Now it is no longer missing. It is locked inside a fragment of ancient asteroid, waiting billions of years before becoming part of an ocean. The case had moved forward. But one successful measurement was not enough to close it. If these ancient asteroids really delivered Earth's water, another question immediately followed. Did they deliver all of it? For a moment, the investigation seemed close to an answer. The chemistry matched. The delivery mechanism worked. Ancient asteroids clearly carried water through the early solar system. It was a convincing reconstruction. But scientific investigations do not stop after the first successful result. They keep asking whether the same explanation survives the next measurement. This one did not. The hydrogen fingerprint was only one piece of the evidence. Researchers expanded the comparison to other chemical signatures preserved by Earth. Nitrogen. Noble gases. Independent records that had nothing to do with hydrogen. If carbonaceous asteroids had supplied all of Earth's water, those fingerprints should have aligned as well. Some did. Some did not. The mismatch was small, but it was persistent. That changed the case. The asteroid explanation was no longer wrong. It was incomplete. A correct answer had survived. It simply could not explain everything by itself. The investigation widened. The oceans were no longer the only witnesses. The planet itself began offering new evidence. Far below the crust, beneath the continents and oceans, lies a region of Earth's interior known as the mantle transition zone. It cannot be explored directly, but occasionally, fragments from that immense depth reach the surface. Locked inside rare diamonds, researchers discovered crystals of a mineral called ringwoodite. Under laboratory analysis, those crystals revealed something remarkable. They contained water, not underground lakes, not hidden oceans. Water bound into the mineral structure itself, preserved hundreds of kilometers beneath the surface. This evidence did not replace the asteroid hypothesis. It changed what Earth itself became in the investigation. The planet was no longer only the receiver of incoming water. Part of its history had remained hidden inside its own interior since the earliest stages of planetary formation. The drop of water returns. This time, it is neither drifting through space nor falling as rain. It is trapped inside a crystal that formed deep beneath Earth's surface, carrying a second history alongside the first. The investigation had reached an uncomfortable conclusion. Asteroids explained much. Earth preserved something more. One successful explanation was no longer enough. Another possibility still demanded to be tested. If icy asteroids could not account for the entire story, perhaps the answer had been waiting somewhere even more obvious. Comets. Comets seemed like the obvious answer. They spend most of their existence far from the sun, where enormous quantities of ice can survive for billions of years. If any objects in the solar system carried enough water to fill Earth's oceans, surely these frozen worlds did. The idea was compelling. It also made a simple prediction. If comets delivered most of Earth's water, their chemical fingerprint should closely resemble the oceans we see today. For years, that prediction remained difficult to test. Astronomers could observe comets. They could measure the gases escaping as sunlight warmed their surfaces. But remote observations could only take the investigation so far. Eventually, the evidence came directly from a spacecraft. The European Space Agency sent a mission to rendezvous with a comet and travel beside it as it approached the Sun. Instead of watching from millions of kilometers away, the spacecraft sampled the gases flowing from the nucleus itself. Among those measurements was the same forensic fingerprint that had transformed the asteroid hypothesis. The ratio between ordinary hydrogen and deuterium. The expectation was straightforward. If comets had supplied Earth's oceans, the two signatures should be similar. They were not. The comet's water carried roughly 3 times more deuterium than Earth's oceans. The discrepancy was too large to dismiss as experimental uncertainty. That changed the investigation. The most intuitive explanation had failed its defining test. Ice alone was not enough. A comet could contain vast quantities of water and still not be the primary source of the oceans covering Earth today. The spacecraft had not disproved that comets contributed water. It had disproved something much narrower. They could no longer stand as the universal explanation. The investigation became more careful. One comet had failed. That did not automatically eliminate every comet. As astronomers examined other members of the comet population, they found that not all of them shared the same chemical fingerprint. Some differed dramatically. A few appeared much closer to Earth's oceans. The solar system had turned out to be more chemically diverse than the simple picture first suggested. That prevented a second mistake. Just as asteroid delivery had not explained everything, comet delivery could not be rejected completely. The evidence supported neither extreme. The drop of water returns. This time it drifts through the glowing cloud surrounding an active comet as sunlight releases ancient ice into space. It carries a fingerprint, one that almost matches in some places, one that fails completely in others. The investigation had now tested its 2 strongest single-source explanations. Both survived. Neither survived alone. Only one path remained. The answer would have to come from evidence that had never depended on either hypothesis in the first place. The investigation had exhausted its simplest answers. Ancient asteroids carried water. Comets carried water. Neither could account for every measurement on their own. If the case was going to move forward, the next evidence had to come from somewhere completely independent. It did. Not from space. From deep inside the Earth itself. Researchers studying diamonds formed hundreds of kilometers beneath the surface discovered tiny inclusions of ringwoodite, a mineral stable only under the immense pressures of the mantle transition zone. When those crystals were examined, they revealed water locked inside their atomic structure. This was not liquid water hidden beneath the planet. It was water bound directly into the minerals that make up part of Earth's deep interior. That changed the role of the planet in the investigation. Until now, Earth had appeared to be little more than the destination. Now it became a witness. Part of the story had been preserved beneath its surface since the earliest stages of planetary history. The investigation widened again. If water already existed within Earth's interior, while additional water arrived from space, then the search was no longer about finding one missing source. It was about determining whether independent evidence pointed toward the same reconstruction. Another line of evidence soon arrived. Not from meteorites that had fallen naturally to Earth. From pristine asteroid material collected in space and returned directly to laboratories. Modern sample return missions brought untouched fragments from primitive asteroids back to Earth without the contamination that accompanies most meteorites after they pass through the atmosphere. The results strengthened what earlier laboratory studies had already suggested. These ancient bodies preserved hydrated minerals carrying water with chemical characteristics remarkably similar to those found in Earth's oceans. The investigation changed again. The asteroid evidence no longer depended solely on rocks that had survived a fiery passage through the atmosphere. Independent samples reached the same conclusion. Separate investigations were beginning to agree. One final question remained. Could the physics of planetary formation produce the same picture that chemistry was now describing? Computer simulations reconstructed the violent early solar system, where young planets migrated. Primitive asteroids were scattered inward, and countless impacts reshaped the growing Earth. Those simulations consistently produced a world where multiple pathways supplied water. Some survived from Earth's earliest building materials. More arrived through water-rich asteroids over millions of years. Comets may have added a smaller contribution, but not one large enough to dominate the entire inventory. For the first time, planetary dynamics, laboratory chemistry, deep mantle geology, and returned asteroid samples all pointed in the same direction. Not toward one dramatic event, toward a reconstruction built from several independent processes. The drop of water returns. It no longer belongs to a comet, or an asteroid, or the deep mantle alone. It carries traces of each. The investigation had stopped searching for a single birthplace. The evidence no longer supported one. The investigation began with an impossible contradiction. Earth should not have possessed permanent oceans. Now every major line of evidence had been tested against that claim. No single explanation had survived untouched. No single explanation had survived alone. The oldest water preserved inside Earth's mantle showed that part of the planet's history had remained hidden since its earliest formation. Primitive asteroids demonstrated that enormous quantities of water-rich material moved naturally through the young solar system. Returned asteroid samples reinforced that conclusion without relying on meteorites that had fallen to Earth. Comets remained part of the story. But direct spacecraft measurements showed they could not account for the oceans by themselves. Each investigation had started independently. Each used different instruments, different measurements, different branches of science. Yet all of them began pointing toward the same reconstruction. That changed the nature of the case. The question was no longer which source was correct. It had become, how did several real processes combine to produce the planet we see today? The original drop of water returns. It looks exactly as it did when the investigation began. Nothing about its appearance has changed. It still rests on a fingertip. It still falls as rain. It still gathers into rivers before reaching the sea. But it no longer carries a single history. Part of its story reaches back to water preserved inside the materials that built the young Earth. Another part traces through primitive asteroids that crossed the early solar system billions of years ago. Some fraction may even record contributions from icy bodies that wandered inward from much greater distances. Current evidence cannot assign an exact percentage to each path. It does not need to, because the strongest reconstruction no longer depends on one source replacing another. It depends on independent evidence converging on the same conclusion. A drop of water is not simply something that belongs to Earth. It is a surviving record of planetary formation, asteroid chemistry, deep mantle geology, and the chaotic evolution of the early solar system, all preserved inside the same ordinary molecule. The investigation closes here. Not because every uncertainty has disappeared. The precise contribution of each source remains an active area of research. It closes because the central contradiction has been resolved, as far as the evidence currently allows. Earth's oceans did not come from one birthplace. The strongest scientific reconstruction is that they emerged through multiple interacting planetary processes whose combined history is still preserved in every drop of water on Earth.